Question 10, Part B. On a dark night, two ships, Saga and Hero, sail parallel to a straight coastline on which there are two lights of equal brightness, 16 kilometers apart. Suppose the coastline is represented by the x-axis, where the origin O is chosen to be the midpoint of the light sources. It is known that the total brightness from the lights on a ship at point P, x, b, is I equals 1 over b squared plus x plus 8 squared plus 1 over b squared plus x minus 8 squared. Part 1. Show that di dx is equal to negative 2p over q, where p is equal to x plus 8 in brackets times b squared plus x minus 8 squared all squared plus x minus 8 in brackets times b squared plus x plus 8 squared all squared. And q is equal to b squared plus x plus 8 squared all squared times b squared plus x minus 8 squared all squared. Express I using negative indices rather than reciprocal form, then differentiate using the chain rule. So I can be expressed as b squared plus x plus 8 squared all to the power of negative 1 plus b squared plus x minus 8 squared all to the power of negative 1. Now we can differentiate I with respect to x. So applying the chain rule by first differentiating the outer function, which is this raising to the power of negative 1. So this negative 1 comes out to the front, and that occurs for both of these terms. So we have a negative 1 coming out here and a negative 1 coming out here. Then we need to multiply by the derivative of the inner function, which is b squared plus x plus 8 in brackets squared. Now b is a constant, so we don't need to consider that one. So we need the derivative of x plus 8 in brackets squared, which is 2 times x plus 8. So di dx can be written as negative in brackets b squared plus x plus 8 squared to the power of negative 2 times 2 times x plus 8 minus b squared plus x minus 8 squared all to the power of negative 2 times 2 outside of x minus 8. Expressing di dx using positive indices now, so in fraction form, and also factorising out negative 2 from both of these terms, we get di dx is equal to negative 2 outside of x plus 8 over b squared plus x plus 8 in brackets squared all squared plus x minus 8 over b squared plus x minus 8 in brackets squared all squared. The final step is to combine both of these fractions by finding a common denominator. And the simplest way to do that is to multiply this fraction here by this denominator, and then multiply this fraction here by this denominator. So we end up with di dx is equal to negative 2 outside of x plus 8 in brackets times b squared plus x minus 8 in brackets squared all squared plus x minus 8 in brackets times b squared plus x plus 8 in brackets squared all over b squared plus x plus 8 in brackets squared all squared times b squared plus x minus 8 in brackets squared all squared. Note that the numerator here is p and the denominator here is q. So di dx is equal to negative 2p over q as required. To answer parts 2 and 3, you may assume the following factorisation given by a computer package that p equals 2x times x squared plus 64 plus b squared plus 16 times the square root of 64 plus b squared in brackets times x squared plus 64 plus b squared minus 16 times the square root of 64 plus b squared in brackets. Part 2. Saga sails parallel to the coast at a distance of 15 kilometers from the coast. By considering di dx, show that as Saga sails from left to right, the brightness on Saga increases to a maximum when x equals 0 and then decreases. Find stationary points by solving for x the equation di dx equals 0. From part 1, di dx is equal to negative 2p over q. So di dx equals 0 when p in the numerator equals 0. So using the fact given and letting b equal 15, P can be expressed in factor form. So P is equal to 2x times x squared plus 561 in brackets times x squared plus 17 in brackets. Letting each of these factors equal 0, we can see that 2x equals 0 is solvable to give a real root. The other factors are not solvable to give a real root. So the equation P equals 0 has one real root at x equals 0. Next, consider the sign of di dx either side of x equals 0. Now the next point to note is that the denominator q is greater than 0 for all real x. So we're not considering or even interested in q at this point, since we know it's going to be greater than 0. Now p is less than 0 for x less than 0, and p is greater than 0 for x greater than 0. Now if we consider p, and we'll go into this into a little bit of detail, we can see that p is a product of these three terms. Now x squared plus 561 is positive for all real x. X squared plus 17 is positive for all real x. The only term that changes sign depending on the value of x is 2x. So when x is less than 0, a negative times a positive gives us a negative, and a positive times a positive times a positive gives us a positive, which is why I made this point here and this point here. Now when p is less than 0, di dx is greater than 0 because we've got this negative here, this negative 2p over q. We know q is positive, so if p is negative, a double negative turns it into a positive. So p is less than 0 for x less than 0, hence di dx is greater than 0 for x less than 0. P is greater than 0 for x greater than 0, hence di dx is less than 0 for x is greater than 0. Expressing what we just found in a table of signs, we have this result, and we can see that the gradient is positive on the left-hand side of 0 and negative on the right-hand side of 0. Therefore, as saga sails from left to right, the brightness increases to a maximum at x equals 0, then decreases after. Part 3. Hero sails parallel to the coast at a distance 6 kilometers from the coast. Describe how the brightness on Hero changes as Hero sails from left to right. Give clear reasons for your answer. Similar to the process used in Part 2, find the stationary points by solving di dx equals 0. In other words, negative 2p over q equals 0. Now this fraction can only equal 0 if p in the numerator equals 0. In Part 3 though, we're given b equals 6 rather than b equals 15. So substituting b equals 6 into the fact given, we can express p in factor form, so p is equal to 2x times x squared plus 260 in brackets times x squared minus 60 in brackets. Now the equation p equals 0 has three real roots at x equals negative 2 root 15, 0, and 2 root 15. Now p is a polynomial of degree 5, so this expression here. And we know that it's degree 5 if we take the 2x, multiply it by x squared, and then multiply it by this x squared, we get a leading term of 2x to the power of 5. Now examining the behavior of p or p of x approaches infinity as x approaches infinity, and p of x approaches negative infinity as x approaches negative infinity. So here is a sketch of the graph of y equals p of x. And here are the three roots. So negative 2 root 15, 0, and positive 2 root 15. Notice that I've split the graph up into 4 regions. So in this region here, p is negative, p is positive in this region here, p is negative here, and p is positive here. Now note that di dx is equal to negative 2p over q, and q is greater than 0 or positive for all real x. Hence, the signs of p and di dx alternate. So in other words, where p is negative, di dx is positive, and vice versa. Expressing this as a table of signs, and here are our three stationary points, so negative 2 root 15, 0 and positive 2 root 15. And then considering some values on either side of those stationary points, so I've tried to choose the most convenient values, so negative 10, negative 5, 5 and 10. We can see what's happening here to the brightness as hero sails from left to right. So increases, local maximum, decreases, local minimum, increases again to a local maximum, and then decreases forever after. So therefore, as hero sails from left to right, the brightness increases to a local maximum at x equals negative 2 root 15, then decreases to a local minimum at x equals 0, then increases again to a local maximum at x equals 2 root 15, and then decreases for values of x greater than 2 root 15.